For the last three problems you see on the test, I'll be testing you on how to write equations and then solve. So let's take a look at the first one here. It talks about Dan bought some chickens. So let's see what he bought. Dan bought a package of 3 chicken legs and a package of 7 chicken wings. Alice bought a package of 3 chicken legs and 6 chicken wings. Dan bought 45 ounces of chicken, while Alice only bought 42 ounces of chicken. How much did each package of chicken wings and legs weigh? Well, we've got some unknowns here. This is what we need to know. We need to know how much did the chicken wings weigh. So let's do this. Chicken wings, we don't know the weight, so we're going to call the weight W. And how about legs? Let's call that one L. So now we've got our two unknowns, W and L, and we can write two equations. And I consider these value equations, even though we don't have a value of money, we're thinking of it as a value of weight. And so here we've got Dan's equation. Let's write his first, since his name came up first. And it was 3 packages of legs. So we know there are 3 packages of legs. We just don't know how much the legs weigh, and that's our unknown there, L. And we have 7 packages of wings, so 7 times the weight of 1 package, W. And his entire package weighed 45 ounces, so it equals 45. Well, Alice bought 3 packages of legs, so we'll write down Alice here and set up her equation. 3 packages of legs, same as Dan, but just different number of wings. So 6 packages of wings. So plus 6W. And this all equals 42 ounces is what she ended up buying. Well, this is a great problem for elimination because we've got L's, we've got W's, equal signs, constants all in line. So let's do this. Let's take Dan's equation and let's just multiply Dan's equation by -1, because if I add them together right now, I wouldn't cancel out the L's. So I need them to be opposite in sign. So I'm going to multiply -1 times each of those numbers. And so I will have a new equation for Dan, and his equation will now be -3L minus 7W equals -45. So when I go ahead and add these together now I get these L's to cancel. And so I have a -1W, or -W equals -3. So look, I had more negatives than positives. That's why I have the minus sign there. Well, again, once you use elimination, you only have a one-step equation. And that one step in this case is to divide by a -1. And so now we've got the weight of 1 package of wings was 3 ounces. So there it is. 3 is the value for the weight of the wings. And so if you want, you can put those units there. And from this point, we can take our 3 ounces and substitute it back into one of the equations. I'm going to pick Dan's equation, and we'll rewrite it 3L plus and then 7W. But in place of W, we're writing 3. And this all equals 45. So we go ahead and do some work there. I'll go ahead and multiply. I've got 21 equals 45. And now I have to start doing some opposite operations. So the thing about the elimination method, it goes really quick until you get to this part. When you solve for your second variable, it's not solved for typically. And so we have to do some operations to get it by itself. So now we have 3L equals, and do that subtraction, we got 24. And so we go ahead and do that last step of dividing by 3, and we've got the value of L. And so in this case, L, the amount of weight of the legs, was a little bit more. It was 8 ounces. So there it is. Legs were 8 ounces, wings were 3 ounces. Well, here's another problem. It talks about Jason. He bought 3 pounds of nails, 5 tubes of caulk for $34. Jim bought 6 pounds of nails and returned, there's a different word there that we didn't see it at least in the last problem, returned 4 tubes of caulk for $40. Find the price of a pound of nails and a tube of caulk. And so let's go ahead and do this. We've got two value equations in this case. See, Jason bought the 3 pounds of nails, $34, and 5 tubes of caulk for $34, and Jim bought some items, and those cost $40. So let's go ahead and write down our variables, what we have here, what we're looking for. Price of a pound of nails. Let's call that one N. And a tube of caulk costs, well, we don't know. That's the unknowns. We'll say C. And so let's go ahead and write down the two equations. We've got Jason first. So Jason bought 3 pounds of nails, so 3N. And, so and means plus. So we're going to add on the 5 tubes of caulk. And that cost, well, we don't know, so we'll say C. So 5 times the cost of the caulk is the cost of all of that added to the cost of the nails. N times 3 is the cost of the nails altogether, and it totals $34. Jim, well, Jim, he bought, it says, 6 pounds of nails, so 6N, but he returned. Ooh, what does returned mean? It means minus. We're going to take that away because he's getting that money back. He returned 4 tubes of caulk, and that totaled $40. Well, that tells us something about the caulk compared to the nails. The nails are going to be a lot more expensive because he returned a bunch of this caulking, and he ended up spending more money than Jason did. So we can't add the equations together quite yet. We need to first change one of the equations. And it would be easiest just to change Jason's equation. Let's go ahead and multiply his equation by -2. And this will eliminate the n's. See, now we have a -6n minus a 10c equals -34. So we can add this stuff together, and it will give us our answer for at least the amount, well, at least a one-step equation for the amount of the cost of the caulking. And so we go ahead and do this work. We cancel out our n's. Those cancel out. And so what we have left is a -14c equals, and we go ahead and do this work here, we have a positive 14. And so we've got an issue here. See, I made a mistake. See, I'm getting a negative number, so I made a mistake in there somewhere. Does anyone see where I made my mistake? Well, hopefully you already spotted it. Again, I know I made a mistake because I'm ending up with a negative number for the cost of the caulk, and that can't be. I can't get money back every time I return something. No, the mistake was right here. It should not be 34. I didn't multiply the -2 by the 34. That's what I forgot to do. So making little mistakes, you'll see your mistakes if you think about what your answer is at the end. And so I saw it, and so I fixed it. And that makes a -78. Made another mistake there. It should be 68, -68, when I go ahead and do that multiplication. So let's go ahead and fix that one more time. Hopefully I get it right this time. So -68 is the number I have there. Again, I saw the error as I was doing it because I was getting a negative value for C. So let's go ahead and fix our problem from here. So 68, I got to take that away from 40, and now I'm getting a negative number. And that's good because I'll end up canceling out those negative numbers when I do my division. See, when I divide by that -14, I end up with a positive answer. So C equals 2, and that makes sense to me. $2. Okay, I'm going to spend money when I buy something. That makes sense to me. So that's why I know I'm on the right track in this case here. And so let's take a look at the next part, and that is just to find the value of the nails. So let's go ahead and substitute. Let's take that 2 and let's put it in for C. How about Jason's equation? It doesn't really matter which one you use, just got to pick one of them. And so 3N plus 5C, but in place of C, we're putting the cost of 1 tube of caulking. And so from there, I go ahead and do some work. I've got still 3N plus 10 equals 34. And so from that point, I can do some opposite operations, and I need to subtract 10 from all sides first. And I now have 3n equaling 24. And so from this point, I just have one step, and that is to divide by the 3, and we have our value for n. So n equals 8, and that makes sense. $8 should have been more than the cost of the caulk, because here Jim ended up spending more money even though he returned 4 tubes of caulking. Well, let's take a look at the last problem. And in this one it says Tom currently has 5 comic books in his collection, subscribed to receive 5 new books each month. His uncle has 145 in his collection, but sends 5 to each of his 3 nieces each month. In how many months? So there it is. There's our question. How many months? We don't know. So let's assign a variable there, m. Will they have the same number of comic books? How many will that be? So how many books will that be? So we'll call that b. So let's go ahead and write an equation for each of these. We have Tom, his equation. The number of books, they want to know that. We don't know that number after the number of months he subscribes for. But he currently has 5. So this is a starting point. So starting point, that means we have a constant. And so it's going to be kind of in this slope-intercept form. You'll see that as I write the equations. So he starts with 5, and he subscribes to receive 5 new books each month. That's a key word there. It tells me I'm dealing with my variable amount. And so I'm going to write down 5m. I don't know the number of months, but I know he receives 5 each month. Let's take a look at his uncle. His uncle has 145 books. That's what he starts with. So his amount of books at the end of the number of months, b, equals, well, he starts with 145. And he sends tells me it's going to be a negative, sends 5 to each of his 3 nieces. So how many, and he does this each month, so that tells me that's my variable amount. But how many does he send away altogether? Well, 5 to each of the 3 nieces would be 15 books during the month. And so I'm going to make that, since he sends it away, it's going to be a negative 15. So he's taking away 15 books each month from his collection. Well, this is a great substitution problem. So I'm going to take the Tom's equation. Again, they want to know when they'll be the same. So I'm going to take Tom's equation and put it in place of b in his uncle's. And so let's go ahead and rewrite what we've got now. So we've got a 5m and a plus 5, that's Tom's expression there, and his uncle's is negative 15m plus 145. So I can go ahead and do some opposite operations here. Isolate the variable. So I'll subtract this 5 from all sides. And I'll also add this 15m to both sides. And I'll end up with a 20m equals, and I have 150. And so from there, I'll do some, oops, I made another mistake there. Does anyone catch what I ended up doing? And so let's check. So my mistake was right here in the 150. And so in this case, I need to end up subtracting. You see, I was going too fast. I had a minus sign here, which was right, but I should have taken away that 5 from the 140. So that ends up 145. So that ends up being 140. So from that point, I can go ahead and solve by dividing by 20 on both sides. And I get these zeros to cancel. So all I have left with is 2 into 14, which is 7. So 7 months. There's part of the answer. We've got one part, but we still need to find the number of books. Well, the books, that's just when we take this 7 and we substitute that back into the equation. Now, it doesn't matter which one. I'm going to pick Tom's equation. So in place of that m, I'm going to put 7 months. So 5 times by 7 plus the 5. Well, that just makes 35. And 35 and 5, makes 40. So there it is, 40 books after 7 months. So you see, I made a few mistakes, but I caught my mistakes by looking at the problem and seeing if it makes sense.